darlings, today we're going to start naming binary covalent compounds. So, a binary covalent compound is just two nonmetals. And let's make sure we remember where those nonmetals are. Let's highlight the staircase, make it big and bold, and anything that's touching the staircase on the left, top, bottom, or right-hand side, besides aluminum, is a metalloid. Everything to the right of that is a nonmetal, including hydrogen off to the side, and that's usually forgotten. In this case, I didn't actually highlight the noble gases. I probably shouldn't have highlighted helium either, sorry about that, because those noble gases won't actually form a compound. They already have their octet, so they won't readily combine with any other elements. The ones that may would be the ones closer down to the bottom, just because they have larger shells and therefore have less attraction to the nucleus. And we want to make sure that those electrons are shared. So, here are some rules for naming binary covalent compounds. First, the least electronegative atom goes first. Okay, so remember, electronegativity, it's an atom's attraction to another electron. And in case you forget the trends, they're located right on table S for you. So, table S has properties of each of the elements, and about the middle column has electronegativity values. These don't have any units, but you will be able to look at them and compare them one versus another. These electronegativity values also help us determine if compounds are nonpolar, polar, or ionic as well. So, the second rule for naming binary covalent compounds is that if there's a prefix, if there's more than one of the first element, add a prefix. So the first example is N2O. Since there's two of the first element, two nitrogens, we add a prefix, di, so make it dinitrogen monoxide. The second example is just NO. There's only one nitrogen, so we don't actually add a prefix for it. This table on the right-hand side shows you all of the symbols or all of the prefixes. Make sure you memorize these and get these into your review sheet. You need to know them. We'll fill in this last little column in just a bit, though. The next rule is that we always use a prefix for the second element, even if there's only one. So the first example here is ClF, chlorine monofluoride. We put the prefix mono in there because it's the second element. The second example is ClF5, so we add the prefix penta in there because penta is the prefix for, or is the name for 5. The next rule is to change the ending of the second element to IDE. So oxygen becomes oxide, hydrogen becomes hydride, fluorine, fluoride, etc. Next, if an element begins with O and the prefix ends with A or O, drop the last letter of the prefix. The example here is CO, which is carbon monoxide. Typically we would actually have, if we kept that prefix, or that O, we'd have monooxide, meaning two O's in there. So I filled in the rest of the table for you, and make sure that this gets filled in on your notes as well. So mono becomes mon. Di and tri still say the same because their prefix ends in I. Tetra becomes tetra. Penta is pent. Hexa hex. Hepta hept. Octa becomes oct. Nona is non. And deca is just dec. So we change all of these prefixes so that we drop their last letter if it's an O or an A. And that's only with an element that begins with O, and our only non-metal element that begins with O is oxygen. So we generally use that rule just for oxygen. And the last little rule is just pretty much a word of wisdom. Don't reduce down the formulas. We'll talk about empirical formulas and molecular formulas a little later on, but if we have N2O4, in ionic compounds we would have reduced this down to NO2, but this isn't ionic. It's a covalent compound because these are two nonmetals. So keep the 2 and the 4 as is. So here are some examples. We've given you the formula. You go ahead and create the name. Now, remember, pause me when needed. So this first one is phosphorus pentachloride. So we have the first element is phosphorus. There's only one phosphorus, so we don't need a prefix for that. Remember, only the second element needs all the prefixes. there's 5 chlorines, so the prefix for 5 is penta, and then we changed the last part of the name chlorine to chloride. Go ahead and do N2O5. This is dinitrogen pentoxide. Notice here we actually remember to eliminate or get rid of the A in penta. Unlike up here, we kept the A. We got rid of the A in pentoxide because the element itself begins with the letter O. Go ahead and do Cl2O. Here we have dichlorine monoxide. Again, we got rid of the O in mono and kept the O in oxygen to make it oxide. We have PBr3 now. Go ahead and pause. Here we have phosphorus tribromide. And our last example here is SCl4. This is sulfur tetrachloride. Okay. Oops, second to last example, sorry, number 6 is BRF. Alright, did you remember to not have the prefix in front of bromine because there's only one bromine? There's only one fluorine, but we always keep the prefix for the second element. Okay, so in this case, each of these examples have mistakes in them, so you have to find the mistake. Go back through your notes after I've given you the first example and check to see what the mistake is. Okay, so this first one is CuF3 copper trifluoride. Pause me, go through the notes. You should have said that copper is a metal, so it can't covalently bond to fluorine. So copper and fluorine would be an ionic bond instead. So you have to go back and use the rules for ionic bonds. And that's copper 3 fluoride. The second example is BRI, bromine monoiodide. This one's a little tricky, so go back to your notes. Bromine is actually more electronegative than iodine, so iodine itself goes first. Remember, the least electronegative element goes first. So the name should have been, actually the formula should have been IBR, and that's iodine bromide. Oh, I'm sorry, that should have been iodine monobromide. So we found a mistake in my fixing here. Let's change that. Okay, make that monobromide. And the iodine doesn't need a prefix because there's only one of them, and it's the first element. Bromine is the second element, so it definitely needs a prefix. The third example is N2O5, dinitrogen pentaoxide. Kind of gave you a hint there by not saying the A. Oxygen's an element that begins with O, so we drop the A from the prefix, penta. Instead it's pentoxide, so it's dinitrogen pentoxide. We have a few more examples. CS2, monocarbon disulfide. In this case, there's only one carbon, but it's the first element listed, so we actually don't need the prefix mono. Instead, it would just be carbon disulfide. Number 6 is ClF, chlorine fluoride. If you saw my mistake from before, fluorine is the second element listed and it needs a prefix no matter how many there are. So this should be chlorine monofluoride. And the next example, this should be example 7, not 3. So CHBr2, carbon monohydrogen dibromide. These rules only apply to binary covalent compounds. Carbon monohydrogen dibromide, there's actually 3 different elements listed there, and we will name that differently later on. Okay, but since this is not a binary, meaning that there's not only two elements listed, it doesn't follow our rules. So we'll go through naming binary ionic versus binary covalent. We have some similarities. First, the least electronegative atom goes first. We know in ionic compounds, the metals go first. Well, metals are actually less electronegative than nonmetals. And the other similarity is that the second element ends in IDE. That's the same thing for binary ionic versus binary covalent compounds. The differences: binary covalent uses prefixes. Don't put a prefix in an ionic compound. And ionic compounds use Roman numerals occasionally when you need to see that there's more than one oxidation state. So for a quick summary, binary covalent compounds are two nonmetals. Make sure you memorize those prefixes, especially for the rules for oxygen, and use those rules. They will be a lifesaver for you. So let me know if you guys need any help. Take care and have a great day.